Alright kids, I'm back. Every time I think I do a short video, I don't do a short video, so my bad, okay? Alright, so this is the second part of Tuesday's lesson. We're gonna start story problems. I'll get as many as I can done. Sorry, that was my knuckles. Not, I'm technically only have like 20 minutes left in class, but whatever. Alright, here we go. So this is 6.2 continued, now that we know about right triangles. So, story problems I warned you about. Here we go. So here's some terminology, okay? So if you are at eye level, whatever the eye level might be, maybe you're on the ground, that's eye level, maybe you're on top of a building, up there's eye level, whatever. So if you have eye level, you're at eye level, that's one side, okay, that's one side of your triangle you're going to build. And if you look up, so your line of sight is looking up, the eye level and the line of sight at which you're looking is what builds that angle. That is called angle of elevation. So since you're looking up, it's angle of elevation. Okay. So if I were to draw this triangle that I actually had built off of this line of sight and eye level, where's my blue? It would have been this. This is your eye level, and this is your line of sight. And then of course you'd have other information, and then you would have connected to make a right triangle. Okay. We'll have scenarios where we have right triangles. If you're at eye level and you look down, so your eye line of sight is looking down, so this dude's looking down. I don't know why my dude looks so weird, but whatever. That makes an angle of depression. Okay. So let me clean this up. So your angle is always built off your eye level, and then if you're looking up or down. So this is the angle you would have built. Okay. If you would have built the other angle, if you were to look down, here is your, again, eye level, but this time you looked down, and so the angle that you built is that angle right there. So that's where people screw up. Your angle is always built off of your eye level, and then you go from there. Okay, your eye level, and then either you're looking down or you're looking up. Okay, so that's what you need. Angle of elevation is looking up. Angle of depression is from looking down. Okay. Alright, now fun stuff. Here we go. Story problem time. I'll warn you to get these story problems printed or whatever, because I would normally print them and copy them for you guys to have in class. Except for this one. This one is, you guys would be writing it down. So here we go, write it down. Here's an example. From the top of an observation tower, or observation deck, whatever, 132 feet high, the angle of depression of a campfire is 20 degrees. How far from the base of the deck tower is the fire? Alright, we gotta get a picture. Sometimes these pictures are given to us, sometimes you have to draw them yourself. And when I was taking 1800, I hated these story problems because I had to draw the pictures. I'm terrible at imagining, so it's going to take practice if you have to draw them, okay? So that's our first goal, is we got to draw the picture. Alright. Here we go. So, where am I at? I don't know. Oh, sorry. You know, brain fart. I have not had my coffee today. Alright. So, we have an observation tower. So here's my tower. Okay. Observation deck, whatever you want to call it. And homeboy's up here. Okay. and he's looking down. It says the angle of elevation to a campfire. Okay, here's my campfire, whatever, there's my fire. Okay. The angle of elevation is 20 degrees. Okay, alright, so this is my right triangle. How do I know I have a right triangle, ladies and gentlemen? Because we're assuming that tower is vertical. It is perpendicular to the ground. So anytime you have a building, you could assume it's perpendicular. It's not leaning. Okay, that's how we have a right triangle. Alright, it says how far from the base of the deck, so here's the base of the deck, to the tower is the fire. So they want to know this distance. Okay, I'm going to label it. I'm going to label it something. I'm going to label it X. Okay, I want to know this distance. Okay. Alright, we need to also label our angle of depression. It says top of an observation deck, 132 feet high. Oh, we can label that too. Sweet, 132 feet high. We have this side length. Okay. The angle of depression of the angle of depression of a campfire is 20 degrees. So this person is looking down. Angle of depression, looking down. So it's looking down at campfire. But remember what I told you, okay? So is this angle right here 20 degrees? Your angle is always built off of your line of sight. This is your line of sight. This is where people get messed up. And this is your angle of depression, looking down at the fire. Okay? So this is your angle of 20 degrees. That's your angle of depression. It's always built off of your line of sight. Okay? This guy is not 20 degrees. Everybody clear on that? Yes, Sam. I hate not having class, Sam. Alright, now if you notice, we're trying to work with this side. The base is what we want. We have the height of 132 feet. We can't use Pythagorean theorem, okay, to find this side because we don't have the hypotenuse. Is everybody cool with that? Can't use Pythagorean theorem because we don't have enough side lengths. Okay, so I'm going to make that little note. Can't use Pythagorean theorem because not enough side lengths. Okay. Alright, so we're going to have to use an angle. Alright, well here's the deal. You can actually do this two ways. Okay, let me show you which two ways you can do this. Okay. Alright, I'm going to draw another triangle. Somebody may say, hey Sam, I'm going to draw my picture over. Okay, I'm going to color coordinate this. I got this. And I got this. Okay. Somebody say, hey Sam, why don't you make a rectangle? Okay. Right, because we have this angle. This is 20 degrees. Okay, we have that angle. That's the angle I want to work with. We know this is 132 if this side's 132. And we know if this is length x, this is also length x. So you could use this upper triangle. You can build it. Somebody may not have realized that, or maybe you couldn't draw that, or maybe there's circumstances where you're stuck with using the original triangle. Okay, so or go back to our original. Okay. We got our base is what we're looking for. So our hypotenuse, which we don't know, but 132. But say I wanted to use this angle because we have this side of the tower and we have this base. Okay, if this is 20 degrees from our angle of depression, okay, what would the red angle be? And somebody would say, Sam, Well, if you take your 20 degrees plus the red angle, that should equal 90 degrees because it's a rectangle. So this has got to be 70 degrees. So you can actually find that other angle, okay? I don't remember the definition of that. My geometry is real, janky. I don't know if it's complementary. I don't know what it is, but they add up to be 90 degrees, okay? So you technically could use that triangle, okay? So either you're using the 20 degree one, okay? Highlight it this side. Okay. So you would use X, 132, or 20 degrees. Or if you realize that you could find this angle, 70 degrees, 132, and X. That is your choice. Okay? That is totally your choice. It is up to you. Whatever you see, whatever works, you can use either one. So, or. Either one is fine. Okay? So I got that from our original. Just made a rectangle. Those, okay? The biggest thing is understanding that 20 degrees, that is your angle of depression, not the 70. Your angle of depression or angle of elevation is always made off of the line of sight and then looking down or looking up. So that's where you can't mess up at. Okay? Alright, I'm going to use the 20 degrees. So, which trig function uses, let's label this, according to 20 degrees, this is the opposite side, this is the adjacent side. Okay, this is my right angle, there's my hypotenuse. Okay, uses, so which trig function uses, because we're going to use 20 degrees, opposite and adjacent. And somebody would say tangent or cotangent, it's your choice. Okay, so I'm just going to do tangent, it doesn't matter. So tangent, remember you always plug in the angle, whatever angle you're working with, whether you know it or don't know it. So either a variable should be there or a number. Tangent of 20 equals opposite over adjacent. Okay, you're using this side because you got to find the x, that's got to be involved in your equation. So tangent of 20 degrees equals opposite 132. Oh, look, we know that. Over adjacent, which is x, that's what we're solving for. So, solve for x. Clear fractions. Multiply both sides by x. Divide by 20, tangent of 20 degrees. If I just bust out singing, my bad. I got my headphones in. Alright, okay. This is the exact distance that the fire is away from the base. Okay, so this is exact. That's why I have feet. Don't forget your units. Okay. If you would have did cotangent, it would have been a little bit different, but it would equal the same thing. Plug them both in the calculator and they both match. Okay. What if you wanted to approximate? Okay, how would you approximate? You go to unit circle. Find tangent of 20 degrees, etc. Okay, so it would be 132 divided by whatever this number is. Okay, go on the unit circle. 20 degrees, approximate that bad boy. Whatever that simplifies to be, 132 over that number. Okay, I'm going to always ask you exact, so you're safe. But homework might ask you approximations, you should know how to do it. Okay, now we're going to get into the other story problems from the handout, which will be posted on, what is that called? Canvas. So before you should have watched this, you should have had it. I'm going to warn you. Alright, we're going to do number 1. From the handout. And I'm just going to write some information. I'm going to read it. Oh, let me put it right here in front of my face. Here we go. So we got to get through as many of these problems as we can between today and tomorrow. Between Tuesday and Wednesday. It says a wire runs from the top of a vertical telephone pole that is 20 feet tall to a stake in the ground to the left of the base of the pole. If the wire makes a 60-degree angle with the ground, find the distance between the stake and the base of the pole. Simplify your answer. Alright, kids. Some information. Okay, it says a wire runs from the top of a vertical pole that is 20 feet tall. So I'm just going to write from now, pole 20 feet tall. Okay, to a stake in the ground to left pole. Stake left of pole. Okay, the wire and the ground, so you got to pay attention. Wire and ground make 60-degree angle. So you got to know what builds that angle. Okay. All right, we have to draw this. Let me take a drink of water. All right, kiddos, let's draw our picture. So we have a telephone pole. Those are those big wooden poles, people. Okay. And a wire runs to the left of the pole to a stake in the ground. There's my ground. There's my pole. And the pole is 20 feet high. Okay. And it says, so this is the ground. Here's the stake. Okay. This is the wire. Alright, there's my picture. The pole is not leaning, so it's 90 degrees. Okay. The stake to the left of the pole. The wire and the ground make a 60-degree angle. So you got to make sure which angle you're talking about. If it said the wire and the pole, this would be your 60-degree angle. So make sure you're labeling everything correctly when you draw your picture. Okay? The question is, find the distance between the stake and the base of the pole. Okay? So distance between stake and pole. So we're going to call that X. So there, I've labeled it. Okay. Alright, so now we have everything labeled. We have a degree, we have one side. Again, can't use Pythagorean theorem because we don't have enough sides. We don't know the hypotenuse. That would be the hypotenuse, FY. And then this distance from the stake to the ground. Okay. Alright, so we're going to use 60 degrees. We're going to use this side, and we're going to use 20. That's all the information we got. We got to use the X. That's what we got to find. So now let's label. So label according to 60-degree angle. Now, could you find this other angle? Yes, it's 30 degrees. It's famous, and it's got to add up to 90. Somebody's going to be special and find the 30 and use that. I don't care what you use. Do whatever you want. I'm just going to use what I already have. So according to the 60, this is my adjacent side, is my X, and my 20 feet is my opposite side. Okay. So again, the question I ask is, what trig function uses opposite and adjacent? And you would say tangent or cotangent. It's your choice. I'm just going to go with tangent. Okay, that's where I'm going with tangent. So let's set it up. Alright. I'm going to try to squeeze this on here. We have tangent of, you always plug in an angle into any trig function, whether you're on the unit circle, on a triangle, you plug in angles. 60 degrees, which is opposite over adjacent. So tangent of 60 equals 20 over x. Alright, so solve for x, clear fractions, multiply both sides by x. Divide by tangent of 60. Darn it, I'm going to have to get a new sheet, which is fine. Okay. X equals 20 over tangent of 60 degrees. Notice the direction said to simplify completely. And how can we do that? Why? How? That is famous. Angle. 60 degrees, famous on that unit circle. You better know 60 degrees. Okay. So, what is it? Go real quick. 60 degrees on the unit circle. I ain't drawing a whole circle. You know it's going to turn out to be janky. That's your pi over 3. It's the same thing. So that is 1/2 comma root 3 over 2. So we got to find tangent of that. So, tangent on the unit circle is y over x, which is square root of 3 over 2 over 1/2, which simplifies to square root of 3. Okay? So, if it tells you to simplify and it's famous, you got to go to the unit circle and find your your trig guy. So this is really x equals 20 over root 3, and that's exact. It didn't say approximate. It said to simplify. This is how you simplify. Okay? Feet. That's how far away the stake is from the pole in the ground. And you don't have to rationalize, but if your book does, if you're looking in, if I give you story problems, just in case, if it asks you to rationalize, it's optional, but your book might do it optional. How do you spell optional, guys? There we go. You would multiply the bottom by square root of 3, multiply the top by square root of 3, because it's always got to be a form of 1. You would get 20 root 3 over 3 feet. So either answer. Okay. Alright. I wish I could ask what questions, but nobody wanted to do it live, so here I am taping this. Okay, let it all sink in. How we use tangent. We use tangent again because we're using the opposite side and the adjacent side with our 60 degrees. We labeled it according to the 60 degrees. And tangent is opposite over adjacent. Okay. Solve for x. And then simplify using our unit circle. Okay. Alright, let me do another one. This is number 2. I'll read it. A beam from a searchlight is mounted on the ground and hits an aircraft. Okay. At what altitude is the aircraft traveling if the beam is 8,000 feet long and the angle from the beam to the ground is 45 degrees? Simplify your answer. Oh, simplify. Look, 45 is a special one. Alright, here we go. So again, I'm going to write some information down. This is a beam from the searchlight mounted on the ground. Hits an aircraft at what altitude? So the question is what altitude? The beam, just writing this down, it's 8,000 feet long. And angle from the beam and ground make 45-degree angle. Alright. Light on ground. Beam to aircraft. I'm just writing down the information. Alright, so here we go. So you're on the ground. Here's a light. Okay. This is the ground. And the beam hits an aircraft. Say it's a flying saucer. Okay. So this is the beam. And it says the beam is 8,000 feet. Okay, it's a beam. This is my aircraft. Okay, this is the ground. Alright, this is my light. It says, what is the altitude? Altitude of the aircraft. Altitude means what, ladies and gentlemen? Height. So this is what I want to know. There's my x. Okay. So last time I wanted the distance on the ground. This time I want the height. Okay, of the aircraft. Alright, it says that the beam and the ground make 45-degree angles. So here's my 45-degree angle. So you gotta make sure you put your angle in the right spot. Alright, now we're going to label. So again, label according to angle. So we're going to use this 45-degree angle. We have to use the x because that's what we're looking for. And the only other number we have is 8,000. Okay. So, here we go. Which trig function uses, alright, let's label. We gotta label this. I didn't label it. I just circled everything. 45 degrees, across from the 45 degrees is your opposite. And this is across from the right angle, so that's automatically your hypotenuse. So which trig function uses opposite and hypotenuse? And somebody's going to say opposite and hypotenuse, that's sine. Or cosecant. It's your choice. Okay, I'm going to use sine. I'm always mostly going to use the normal one. Alright, so here we go. I'm going to choose sine. Sine of what angle? 45 degrees. You should always be plugging in an angle. If we didn't know, we would just say alpha. Okay, go from there. Equals opposite over hypotenuse, which is x over 8,000. Solve for x. Multiply both sides by 8,000. There's your x, but it says to simplify completely, so we need to go find this. Find on unit circle. 45 degrees is your, what guys? Your famous one. Your pi over 4. That's square root of 2 over square root of 2. Or square root of 2 over 2, square root of 2 over 2. Your sine is square root of 2 over 2. So you have 8,000 times square root of 2 over 2 equals x. Sine of 45 degrees equals square root of 2 over 2. I just want to show all my work. Alright, simplify that mess. X equals 8,000 over 2 is 4,000. Root 2 feet. Right, there's that guy. I wish I could ask you questions. Where are we at? How much time? 27:05. Alright, I'm going to stop here. I would like to do another one, but I know you have the other video plus this video. So I'm going to stop here. So that means Wednesday's video is going to be as many as I can get through. Might be a longer video. There's my warning. What did the guys tell me this morning? Tell your friends to subscribe me. Thumbs up, guys. Yeah, no, don't tell anybody about my videos. I'm just playing. Alright, talk to you later. Bye.